For today's lesson, we'll be looking at Chapter 3, Lesson 2 on exponents, and our goal is going to be both to use exponents and to simplify expressions that have exponents in them. To start, let's review and go over the basic components of an exponent. An exponent is the small number that we see in the top right-hand corner of a bigger number, and it tells us how many times we should multiply the base number, which is the big number at the bottom, together. So for review, whatever number is it'll end up looking normal size like the rest of the numbers on a particular page is going to be called the base. And that little tiny number we call either the exponent or the power. Both of those words are synonyms, they mean the same thing. And what that does is, since we have the number 4 there, I usually draw out 4 lines to help me remember that the exponent of 4 tells me I should multiply something 4 times. The thing that I multiply 4 times is going to be that base number. So I'm going to take that big number 5, and it's going to stay a big number 5, and it's going to fill each of these categories. So 5 to the 4th power, which is how we would read this example, is going to be 5 times 5 times 5 times 5. And we could do out that multiplication in order to find out the standard form of that number. A couple other important words that we might want to take note of. If we have a number like this, so 6 to the 2nd power, the exponent of 2 is going to be called squared. So squared just refers to an exponent of 2. And if we have something like 7 to the 3rd power, the little number 3 can be replaced by the word cubed. A way that I remember that is that a square is a 2-dimensional shape, so it's the exponent of 2, and a cube is a 3-dimensional shape, and it has an exponent of 3. In each of the following examples, we want to be able to identify both the base and the exponent, no matter what form an exponent is written in. In the first example, 6 to the 5th power, we see a number written in exponent form, meaning that we can see that little exponent shown as the small exponent number up to the right of our number given. In that case, our base is going to be the bigger number at the bottom, so going to be 6. And our exponent is going to be the smaller number that we see at top, so it's going to be the number 5. In the second example, 7.8 times 7.8 times 7.8, we never see an exponent, but we have to think about what it means to have an exponent. An exponent, if you remember back, tells us how many times we should multiply a number together. So since we have 7.8 3 different times, our exponent's going to be 3. Our base is that number that gets repeated over and over again, so it's going to be 7.8. We could have written this expression as 7.8 to the 3rd power. We can have decimals or fractions or any type of number as our base number. In the last example, and this should all be multiplication, we have 7 y's multiplied together. So again, that exponent says that since I have 7 of those y's, my exponent is 7, and my base could even be a variable, because I know that a variable simply represents a number. So y would be my base. If we wrote that in exponent form, we'd have our y as our base number, and 7 would be the little number, the exponent up to the right. When we're asked to simplify a power, just like when we simplify any number, we want to make it in a form that's simpler for us to understand. 2 to the 5th power sounds kind of fancy. Most of us don't know exactly what that means, or if you say that to a lot of people, they wouldn't know what number you're referencing. So in simplifying this, we're actually going to start by making it longer. We're going to write 2 to the 5th power in expanded form. What that does for us is our exponent of 5 tells us that we should have 5 spaces. There's 5 things I'm going to multiply together. Since my base is 2, I know that 2 is the number that's going to fill all of those spots. So when I'm going to solve this, I always try with exponents to save myself some work and to do as much mentally as possible. So I know that 2 times 2 is 4. I also know that this group of 2 times 2 is 4. Got to keep that multiplication, and then I still have that multiplication and that last 2 at the end. Then I know 4 times 4 is 16. I still have that final 2 I need to multiply, so I'm going to get 32 as my answer. I always like to group as many possible groups of numbers as I can to make the multiplication the simplest way that I have possible. We're going to simplify 9 to the 4th power the same way we did for 2 to the 5th power, so I highly encourage you to pause the video, give it a try, and then restart to check your work. If you're more comfortable seeing how this one's done again though, feel free to listen along as I talk us through. Again, I start out by identifying the exponent, which this time was a 4. That tells me I should have 4 spots. I'm going to have to multiply 4 numbers together. This time my base number was 9, so I'm going to put 9. 9 stays the same, it stays big and moves straight across there. Again, I want to try to do as much mental as I can. I know that 9 times 9 is 81. So instead of doing 81 times 9, which I'll probably have to write out on the side of my paper, I'm going to do that other 9 times 9 to get 81. And then the only work I'm going to actually have to write out from a multiplication is whatever 81 times 81 is. So there may be times where I have to go ahead and show my multiplication out over on the side to finish, but by grouping the pairs of numbers, I was able to accomplish this pretty easily with only one multiplication problem. So I get 6,561. That's what I'm going to get when I do 9 to the 4th power. So far, everything we've looked at in this lesson should be a review. We've seen exponents before and we've talked about them, so we've refreshed just to make sure that we know exactly what we're talking about. We're not confusing or messing up anything. The main goal, though, is to apply what we know about exponents and to use them to help simplify full-on expressions. So what I need to remember when I'm solving this expression is PEMDAS, which is our order of operations rule. So if I write up on the top, this just reminds me that the P stands for parentheses, my E is for exponents, then I have multiplication and division, which I want to keep together because I know I'm going to go left to right when those are my next two options. Addition and subtraction have the same thing. We're going to work from left to right and not pay complete attention to whether addition or subtraction is first. So when I want to go ahead and solve this expression or simplify it, again, I'm simply taking this big long string of numbers and I want to turn it into a single number, make it something that's simpler and easy for people to understand. When I look at the order of operations tells me the first thing I should do is the P, which is parentheses. So I have this parentheses and it has a number of different operations in it. So now when I look inside parentheses, I have to see which of those I do first. So after I go through P, I look at the E, which is the exponents. And I do have an exponent here, so that's going to be the first thing that I start with in my simplification process. So I see 7 squared. That tells me it's not 7 times 2, but 7 2 times. So I'm doing 2 spaces. I'm filling them both with 7s. So 7 times 7 I know to be 49, so I'm going to replace that with 49. Just as I've done with simplifying other expressions, I'm going to copy down every single thing that I find in the rest of the problem, except that 7 squared I'm going to replace with 49. That slash just means division. So now my expression looks like this. I no longer have any exponents, so I'm moving on to multiplication and division. I noticed this multiplication symbol out here, but I'm not going to do that first. Remember, I have to finish what's inside of the parentheses because that was my very first step before I go ahead and move outside of them. So I'm actually going to do this 18 divided by 2 next. So I'm going to replace that with the number 9. Again, everything else I'm going to keep exactly the same. And I haven't done any addition yet, but I'm not going to write down that 18 plus 2. Now I've got here, again, even though multiplication comes next, it's not inside the parentheses. I've done parts of what's in there. I have to complete that whole process, that whole part, before I move outside of parentheses. So the next step I'm going to do is my addition. I'm going to do 3 times, then I have 49 plus 9 to give me 58. Now, even though I still have those parentheses left, I didn't really need to show them there. Every operation inside the parentheses is done. That parentheses is just showing me just what single number. So the only thing left I have to do is multiplication. So if I multiply 58 times 3, I should get 174 by following the steps of the order of operations. If you feel pretty good about how to simplify expressions, I encourage you to pause the video right here, give this problem a try, and then catch back up with us as we go over the answer at the end. If not, follow along as I take a look at the steps in the order of operations again. Remembering PEMDAS, I remember that the first thing I do is parentheses. Well, this time I don't have any parentheses to work with, so I'm going to move on to exponents. I do have an exponent. This time it's 2 to the 3rd power. I always have to remember when I see that exponent of 3, it tells me I should have 3 spaces. I have 3 numbers I should fill in. The base this time was 2, so a 2 is going to go in all those spots. So I have 2 times 2 is 4. I have that last final 2, so I'm going to multiply 4 times 2. I'm going to get 8. So I'm going to replace 2 cubed with the number 8. Everything else I'm going to copy straight down. Now I don't have any multiplication, so the next step I'm going to have is division. Instead of 6 divided by 3, I'm going to write the number 2. I still have to carry down that 8 in the subtraction symbol, so I have 8 minus 2, and that's going to equal 6. Last problem before you try some completely on your own. Again, I encourage you to pause the video, give this problem a try in your note skeleton, and pick up with us in just a minute. If you want to see another example, though, follow along as I talk us through this one. As we take a look at the order of operations again, PEMDAS tells us to do the parentheses. I do have parentheses here. Notice that I'm going to do what's inside the parentheses first. So I'm going to take that 2 plus 1, even though I have that little exponent up here, exponent is outside of the parentheses. So I have to do what's inside the parentheses first. So I have 2 plus 1, and that's 3. I'm going to carry down those parentheses, carry down my exponent, my plus and my 5, which I haven't used. Next, after parentheses, is exponents. I'm going to do that exponent since there's just a number in those parentheses, no operation or anything else. I know I'm okay to solve that. 3 squared, or 3 to the 2nd power, tells me that exponent of 2 says I should have 2 spots. My base of 3 tells me I should fill those spots with a 3. I'm going to replace 3 squared with the number 9. So now I have 5 and an addition symbol, so 5 plus 9 is going to give me 14. At this point, go ahead and complete the rest of your note skeleton, and we will discuss these tomorrow. Once you're finished looking at your note skeleton, please go back to Edmodo or stay on Edmodo and answer the couple of quiz questions as we discussed in class that go along with this. Just place your answers from that worksheet and make sure you answer those, and make sure you press submit at the end so that you send those to me and I can take a look at how you did with these before you come into class.